we're going to take the derivative of cosine here. I've just put up on the board the sum formula for cosine because we're going to need that. We'll need it in the context of cosine of x plus h. I've given it to us in a more general form of cosine of a plus b. All right, so I want the derivative of cosine. So here's my graph of cosine, and we're going to have a point x cosine x, and then a nearby point x plus h cosine of the quantity x plus h. And so there's our secant line, and I know that the derivative is just the limit as h goes to 0 of the slope of that secant line. So cosine of x plus h minus cosine of x all over h. So here's where I'm going to use that sum formula to simplify cosine of the quantity x plus h. This is going to become the limit as h goes to 0, cosine x cosine h minus sine x sine h. That's this first term here, and then we're subtracting cosine x and dividing by h. So again, I have three terms on top. The first term and the last term have a cosine in common, so I'm just going to rearrange things and put them together. So this is the limit as h goes to 0 of cosine x cosine h minus cosine x minus sine x sine h all over h. And these three terms, I'm going to break into two groups. I'm just going to pair these up so that I can factor out that cosine. So this is the limit as h goes to 0 of cosine of x, which is multiplied by cosine of h minus 1, and then minus sine x sine h all over h. So here are those first two terms just written in a factored form. Again, I'm going to distribute that division by h to break this up into two fractions. So this becomes the limit as h goes to 0 of cosine of x times cosine h minus 1 over h minus sine x times sine h over h. And just like when we were finding the derivative of sine, the top of both of those fractions is a product of two factors, one of which has h's in it and the other one doesn't. So I'm just going to separate those and say this is the limit as h goes to 0 of cosine x is multiplied by the fraction cosine h minus 1 over h minus, here sine x is being multiplied by the fraction sine h over h. If I did this multiplication, of course that cosine x and that sine x would just be on top of those fractions. So now I have 1, 2, 3, 4 pieces connected with arithmetic. I'm multiplying and I'm subtracting. I'm going to use my product and difference rules for limits and say this is the limit as h goes to 0 of cosine of x times the limit as h goes to 0 of cosine h minus 1 over h minus the limit as h goes to 0 of sine x times the limit as h goes to 0 of sine h over h. For this first limit, cosine of x doesn't have any h's in it. It is constant with respect to h. Again, that's because this was representing a fixed but unspecified point. So this is going to be cosine of x times this limit is 0. Again, when we originally derived it, it was 1 minus cosine h over h, but when we worked out the derivative of sine, we saw that switching the order of the subtraction just gives me the opposite of 0, which is still 0. Minus sine x doesn't have any h's in it. That is constant with respect to h, so we just get sine x. And then the limit as h goes to 0 of sine h over h is 1. So this gives me 0 minus sine x. It gives me negative sine x. So the guess we made based on the graph describing the derivative of sine was correct. The derivative of cosine is negative sine. So what we know now is that the derivative of sine is cosine, and the derivative of cosine is negative sine. Now, it's easy to get confused and forget which one has a negative sign in it. That's one reason I wanted to look at the graphical derivation of things first. If I take a look at sine, starting at 0, sine is going up. It's going to have a positive derivative. If I take a look at cosine, starting at 0, cosine is going down. It's going to have a negative derivative. So the graph can help me remember which one of the formulas has a negative sign in it.